Hello and welcome to everybody on Cloud Fitness. So in today's video, we are going to discuss about the core concepts of Apache Spark. So when I say core concepts of Apache Spark, this is really important because the whole Databricks itself is based on Apache Spark framework. Now since it is based on Apache Spark framework, in this case it becomes very important to know about this Apache Spark, and I do recommend watching my previous videos as well in continuation to this one, because then only you will have the better understanding, right? Now in this video we will focus mainly on the architecture part, on the DAG, on the stages, the tasks that are created, on cores, executors, drivers, as well as the memory usage in this part. So we all know that the very first concept that came into picture was a map reduce concept, right? I have explained it in my very first video in this playlist. Now that was not an in-memory computation, and this is an in-memory computation, right? So we will go ahead and discuss this in detail, but do remember to subscribe to my channel and do hit the like icon on this video. Let me know in the comment section if you have any issues related to these concepts, and if you want me to make video on any other part as well. Now coming on to the Apache Spark concept, we already know that whenever we have to execute something, we have to go to the notebook and we basically write the code, right? This is something that I have discussed in my previous video. Now similarly, when you write anything inside the Databricks notebook, that is a driver program, right? So if I go to basically this, right? So for example, let me just open any notebook, right? So let's say this is the already open notebook. Now if I just execute this part, what is this? This is nothing but this is a code that I am trying to execute, right? This is a code that I am trying to execute. It can be anything, right? We will discuss in detail about what all we can do inside the notebooks, but this is something that I've already talked, that we can execute anything, any print statement inside or anything inside this notebook, right? So the moment I execute it, this is nothing but this is the driver program that gets created, right? Once this driver program gets created, what happens is there's a cluster manager which manages this program that you want to execute, right? So you might want to execute some complex queries, you might want to execute some joins, let's say, right? Now this cluster manager defines that how your join will actually happen, right? Now if you go to the map reduce concept again, if I go back to the map reduce concept, what exactly I told here, there was, let's say you have a file of 1000 rows. Now it gets divided into, let's say two files, and those two files executes in parallel. Now these two files executes in parallel on different machines, right? In the similar way, you have something called as worker nodes. So if you see on the right hand side of this picture that I got online, so this is the worker node and this is also a worker node. So this worker node is nothing but a set of machines, a set of machines on which your part of your code will run. So let's say you are trying to perform, I'm just giving an example, let's say you are trying to perform a join on two tables. Now that join, the half of the data will go to one worker node, half of the data will go to another worker node, right? So that your work can be divided and it can execute in parallel. So this is the overall concept of how Apache Spark actually works. So this worker node is nothing but a machine, and similarly this driver program is also a machine. It is one machine. So driver program is a machine and then worker node is also a machine. Now cluster manager is something that works in between. It tries to manage the data. It tries to see which data should flow to which worker node, right? Now once everything is executed on your worker nodes, the data is, and if you might want to display the data, you might want to show the data in your Databricks. Now if you do such kind of work, in that case all the data after you have performed all the transformation on the worker nodes, the data will come back to the driver program and you will be able to see the data on the screen, right? So this is just a basic thing. We will dive more in detail, no worries on that. So In fact, let me tell you how it happens through this Excel sheet. Now what happens is, I also explained that you have something called as cluster. So if I go to this compute option over here, if you know, I told you we have something called as cluster. Now what does this cluster do? This cluster is a set of machine which will help you to perform parallel execution. Right? If I go ahead and click on create cluster, now once you start once you do any kind of transformation, once you write code in the notebook and you execute it, right, that execution will actually happen on this cluster, right? So it has something called as worker type, it has something called as driver type over here, right? Now same thing I'm going to explain you here. Now what happens is, in the cluster or in terms of Spark, what your data is collected in between by your cluster manager, and then it is sent to different nodes, right? This is your driver program, right? On the right hand side in the green, this is your driver program. It collects your data, like when you start the execution, driver program sends your data through cluster manager. There is a cluster manager in between. Let me write it here, cluster manager. So with the help of this cluster manager, your driver will actually send the data in parallel forms to different nodes. These nodes are nothing but the set of machines. Now these machines will actually have executors inside it. So if you see this node 1, right, this node 1 has an executor which is one machine. This also has one more executor which is another machine, right? Similarly, this node 2 is also, it has different executor. But in terms of Databricks, when we talk about Databricks, one node is equal to one executor. So even if it is not clear, no issues, just hold on for some time, and if you have any issues, you can even replay what I'm saying, right? So this driver actually sends the data to different worker nodes. For example, this is node 1 here, this is node 2 here, with the help of this cluster manager. And then inside that node, basically you have different workers or executors. You have these executors, right? Now these executors, as of now, what I have mentioned is, inside a node you have multiple executors, right? But when it comes up to only to Databricks, this is a general Spark concept that inside a node you might have multiple executors, but only for Databricks, inside one node you will have only one executor. So Databricks basically has one node and one executor inside each node. This thing you need to remember. And then each executor will have different cores, right? So executor 1 has core 1, core 2, core 3, core 4. It has 4 cores actually, right? Now this core is essentially equivalent to the thread. If you understand multi-threading concept, it is same. So each core will actually take one part of the data and it will execute it in parallel. So parallelism is actually defined at the core level, right? So in one particular node you will have executor, and inside executor you might have multiple cores. Now each core will actually work on one partition. Each core will work on one part of the data. So this is an overall thing, but now we will see even in more detail how it works. So if I go back and let me show you this here. So now what I told you is, you have your user program, right? Now this user program goes to the worker. So till now what I explained you is this user program, and then with the help of this cluster manager in between, this middle part, it goes to the worker. And till now I have explained you these worker part and this user program. I have not explained you the middle part till now. So this worker part, again I'll just reiterate. So the moment you write a user program, something happens in between. Spark application is there, you have your cluster manager, it works. We will discuss about this work as well. And then the data goes to the workers, right? Workers are nothing but different machines. Now this machines also, it has nodes, right? Inside each and every node you have executor. For Databricks, one node is equal to one executor, and each executor will have cores where each and every partition of your data will go. So 4 cores basically mean that 4 partition can work in parallel, right, in one executor. Executor is nothing but a machine. So this is one part of it. Now in the middle part, if you see what happens here, whatever code you write in Apache Spark, all the code gets converted in form of RDDs. RDDs are resilient distributed data set. We will talk more about it. RDDs for now, just understand that these are the data structures. These are Spark data structures. Okay. So whatever operation you perform, that gets converted it in form of lineage, RDD lineage. So what you see over here, right, RDDs, this graph. So this is called your DAG, directed acyclic graph. So how does it happen? So let's say you read the data from one particular location. So that RDD is created. The moment you read that data, one RDD is created. Now you try to filter out the data, then another RDD is created. Then you try to aggregate the data, then another RDD is created. So this is how it becomes a lineage. Lineage means one step after the other. Now through your code, you define which step will occur first, right? You first read the data. So the RDD1 is created. Now after that you filter out the data. Now RDD2 is created. So that becomes a lineage. So that is also called your directed acyclic graph, which defines the flow of your transformations. Now this directed acyclic graph is created by the Spark application. Once you create a user program, once you run a user program, this DAG is created. Now once this DAG is created, what happens is, in between, let me go here. So what happens is, if you see, this DAG is created, all the transformations are there. Now DAG is nothing but a collection of RDDs in a proper sequence, right? It is a collection of RDDs in a proper sequence. It is a graph basically. It is a directed acyclic graph. It has edges and vertices. It is a collection of RDDs. Now what happens is, it knows which transformation has to happen first, right? So using that graph, a whole flow is created. A whole flow is created which defines which operation will happen first. So it knows the whole plan. So now you have written the whole code. Now DAG is created. Now Spark application already knows what is the plan. So that is called as your physical plan, right? It creates a physical plan. Now using that physical plan, it knows which operation will happen on which data set, right? So it already knows what is the plan of the data, and based on that it creates stages and tasks. It creates stages and tasks based on your plan. Now what are these stages and plans? Let me in fact go back to this portal itself. Let me open any notebook which I would have run. Let me just open this one. So if I show you here, so for example, if you see what I have done, this is a data frame that is created. Like this is some code that is written. Now if I open this, you will see, okay, so there is only one stage here. So if you see, it says that it has a stage 1 of 1. So there is only one stage here, right? Because there is only one operation that is happening. So now the moment I have written this piece of code, Spark by default, it will create a lineage of RDD, right? It will create a directed acyclic graph. Now using that graph, it has a plan. It knows what to execute where, right? Now what to execute first, what to execute next. It already knows that. Now using that, it creates stages. Now stages, how does it create? Now you have, let's say, 1000 rows. Now if a filter operation has to be performed on all the 1000 rows, it will create one stage out of it. Now if it has to do a group by, now it will create another stage out of that group by. So basically, if you have any kind of transformations, right, and those transformations can be applied on a set of rows together, now in that case a stage is created out of it. So if you did not understand, I'll just repeat. So if you have a set of if you have a transformation which has to be applied on all the rows together, so that creates one stage out of it. After that stage also, what happens is it starts creating tasks. So let me check if something has run previously. Let me just check to show you. if I open this, okay, so here also you can see there is only one task present here. So here also task 1. So basically I don't see any task created here, but because you know, whatever processes I have done these are all only on a subset of the data which do not require any much parallel processing, so that's why there are no tasks created here, and in fact I'm just running a 2-core on a 2-core cluster, that's all. So but in case you know, I'll just reiterate everything because it might be little complex to understand in the first go, but eventually you will understand it. So if you see, this is the code that is written, it is doing some job. What happens, it is creates a Spark job, right? This Spark job, how it is created, this code goes to the driver, then driver has something called as cluster manager, which takes the data, you know, create a DAGs out of it. You have you know, directed acyclic graph created out of it, which shows you the execution flow, you know, on how your transformations will run one after the other, and then based on that a physical plan is created, and using that physical plan job is created. Now this is the job, right? Now using this job you have something called as stages. So stages are created. Right now here there is only one stage created. Now why this stage is created? This stage takes one set of the data and applies some transformation on top of that. Now after the stage is created, you have something called as tasks. Now those tasks, you can actually see it here itself in your production workloads or in your you know, actual workloads. You will see that there are tasks also. Now these states are created if a subset of data can be used on a particular transformation, or also if there is no shuffle involved. So for example, when I say shuffle involved, as I explained in the map reduced video, that after applying the transformation, right, you have to pick up the data from multiple machines, right? So in that there is a shuffle involved, right? Now to avoid that shuffle, stages are created. So if a transformation can be applied on a subset of data in one go without any shuffle, now in that case that particular you know, stage will be created as stage 1. So if there is another set of data, it will create stage 2 for the second transformation, without which will not have any shuffle involved in it. Now from that stage there are further tasks which are created. Now tasks are created based on the, you know, parallelism that you have defined, based on the number of cores which are present, right? Because in the end everything will go to, if I go back to this Excel sheet over here, in the end everything will actually go to these cores, right? Now each task, right, now each task will have partition which will go to this core for execution. So this is an overall view on how you know, Spark execution happens. So you know, I understand it will be difficult to, you know, understand it in very first go, but I do recommend watching this video again. In case you have any questions, do let me know in the comment section. And also remember that there are few concepts which we will talk about later, so that, you know, everything will become clearer and clearer as we proceed. Also, you know, when I say this tag is created, you have this whole process, right, which is explained here. Now this whole process occurs only when you actually perform something on the data, right? So let's say, for example, you wrote a whole code to do filter, you wrote a code to do the join, you wrote a code to do all the filtering and everything. All these things will not happen. Now this whole architecture which I have explained you, this happens only when I try to get the data out, you know, when I try to execute it, then only it will happen. If I don't execute it, as in, like for example, let's say I have read the data and then I have tried to filter it, then I try to group by, right? If I have done only this step, it will not execute this whole process. But when I will try to fetch the data after doing a group by, right? So you have written the code, but you have not fetched the data out. So if I'm trying to fetch the data out, you know, that what will be my, how will my data look like after the group by has been done on it, then only this whole process will happen. Then only Spark will take the your code and it will create a RDD lineage, and then only it will create stages and tasks out of your Spark. Then only it will create stages and stages and tasks, and then it will send it to the workers and executors, because now you have requested that I want the output. Now until you write in the program that you want an output, until that point this will not happen. It will just write it, right? You will understand it as we proceed forward, so no worries on that. And also I would also like to talk about the memory part of it. So when I say memory part of it, if you see, you have executor, right? So you have core 1, core 2, core 3, and all the processes running over here. Now it has some memory associated to it, right? So some part of the memory is reserved. So if you see this 300 MB, so if for a 4 GB of executor, if your executor is 4 GB, now from that 4 GB your 300 MB of memory will be reserved. So if I say if your executor is of 4 GB, right, if your executor is 4 GB, then 300 MB will be reserved for your Spark internal works, right? It is not available to you. So this is the memory distribution. Now in that also you have something called as Spark memory. Now if you try to do any kind of cache, if you try to do any broadcasting, so these are different Spark concepts. If you try to do any caching, if you try to do any broadcast operation, now in that case, if cache has a memory, now caches are also of different types. There can be a memory cache or a non-memory cache, right? So if the cache is a memory cache, so this memory is actually going to get utilized. The storage memory is going to get utilized for your workloads. This execution memory is the actual memory which you use, right? So let's say you want to do any filter operation, so this is the execution memory which will do that filter operation. Similarly, you have something called as user memory. Now this user memory is essentially used for any user defined functions, right? If you do any user UDFs, now in that case it will go to this user memory. So this is how even the memory part is taken care of, but you don't need to go in that detail. It's completely fine if you understood even this part is pretty much it is fine. So essentially you just need to understand that moment you write the program, what happens is a DAG is created, a directed acyclic graph. Now this directed acyclic graph is nothing but set of vertices and edges, right? It is a graph, it is an actual graph with edges and vertices. Now what does this graph do? This graph actually tells you each and every operation sequence wise. Now using that, stages and tasks are created. Stages are created based on shuffles. So in case for a set of row, if an operation has to be performed together, now it goes to stage 1. For another set of rows, if an operation has to be performed all together without taking the data from any other stage, it goes to stage 2, right? Like that, stages are created. Now after that, tasks are created. Now tasks are actually equivalent to the number of partitions that you define. Now tasks are the smaller piece of work or the smaller unit of work which will actually go to your executor core for the working part. Now once everything is done, you can take the data from these worker nodes back to your driver program or back to your UI. You can display it using, there are commands like display. You display it, you will get all your data. This whole plan will execute and it will show you your whole data. So this is how actually Spark works in detail. Do let me know in the comment section if you did not understand. It's okay if you did not understand. We will actually see more in detail about it. So thank you so much for being till here. Do remember to like, subscribe and share. Thank you so much.